Right, consider this question. A solid suspended by a piece of string is completely immersed in water. On attempting to lift the solid out of the water, the string breaks when the solid is partly out of the water. This is because dash. Very good. This is JAMB 1978 Physics question 13. So this question is asking us for the behavior of an object when it is immersed in a liquid. So, and then when it is partly out of the liquid. So you need to learn more about equilibrium of a body in a fluid. And under that, you will learn about law of flotation and at the same time, Archimedes principle. So Archimedes principle is the best to explain what happens here. So, but before we consider the option, let us see certain things that will help us to understand this question very well. Now, when an object is immersed in a fluid, let me make a drawing. Let me make a small drawing of that. So, for example, if this is a bucket tied with a rope, of course, the bucket there will be a tension in the rope. Now, let's say you immerse it inside a container of water, like a well. Now, when this object is completely inside water, the weight of the object is acting downward, and then there is a buoyant force acting on it. This buoyant force is known as the upthrust. So the upthrust. Upthrust is the force that is dragging the body back up. So it's the buoyancy of the object. So that's the buoyant force. So you know that at times every time when you put a bucket inside wells to fetch water, the bucket filled with water will appear lighter. It's because of this upthrust. It is because of this upthrust. And now, how do we calculate that? So, of course, we can calculate this buoyancy by calculating the weight of the object in air minus the apparent weight in water. That is how we calculate the upthrust. Now, according to what we have here, we are so much interested in the tension of the string. The tension in this string will also be equal to the upthrust of this object. So, will also be equal to that. So, to calculate the tension, we are going to just say T equal to weight, apparent weight in air, the weight of the object in air minus the weight of the object in water, or due to the buoyancy. That is weight in water. Let me just call it WW. Now, when the object is completely immersed inside water, you know that it will appear lighter. That is because the weight of the object, it has displayed equal volume of water to its own weight. It has displayed a volume of water that is equal to its weight. That's why everything balances each other. So in that case, when you are dragging, when the object is still inside water, completely submerged inside water, it will appear lighter. That's why it feels lighter when you are dragging it. But what happens when this thing is completely out of the water or partially out of the water? Now, in that case, when it is outside, when it is moving out of the water, so the tension in the string in that case will now appear, when it is completely inside water, the buoyant force will be equal to the tension. They will balance each other. So because when an object is completely inside water, the buoyancy, that is the buoyant force, will increase. So this weight of the object inside the water will increase. So because the weight of the object inside water will increase. That's why the object always feels lighter. So then If it is now out of the water, maybe partially or even or completely. So, but partially in this case, this weight will now become less. So, because when you are dragging it out, it will become less. So, in that regard, the upthrust will now reduce. The upthrust will reduce in that case. So that means if you calculate the weight of the object, the tension in the rope, it will now become more. The tension will be more because this weight has become less. When it was in water, this weight is more. So the weight of the object in water is large. That's why it feels lighter. But when it is outside the water, maybe partially or completely, this weight becomes less. So it means the tension will now increase. You know, when you are subtracting a smaller value from W, it will become more. But when you subtract a big value from W, it will become less. So that's why the upthrust is, the tension is less here, while it is high here. Now, due to the increase in that tension, that's what led to the breaking of this rope. That's what led to the breaking of the rope. So if you now consider the options one after the other, let's see the one that best describe what happens here. So check option A. The option A says the tension in the string decreases as the solid is lifted. No. If the solid is lifted, tension will increase because it is no longer inside the water. You know, remember what I said. When it is inside water, tension will reduce because it will feel lighter. But when it is outside the water, the tension will become large. So that means option A is incorrect. Check option B. The mass of the solid has increased. No. Mass will remain constant no matter the value. So the mass of that bucket remains the same. It doesn't change. So B is not correct. Let's check C. The solid apparently weighs less when completely immersed in water than when partially immersed. So this is the correct answer. Option C. According to what I explained here, it will be lighter. So that is because the weight inside water is more. So if you now subtract it from the original weight, it will now become, the tension will become less. But outside the water, the weight that the object will generate will be less. So that's why the tension increases as you are moving it out. So tension increases. So C is the correct answer. Thank you.